Hi, welcome to everyone's favourite segment, Mailbag. Yes, almost, is it a weekly schedule at the moment? I don't know, but yeah, for a while there I didn't do them. But I've got a whole bunch of stuff, actually two just arrived, well, this morning from the same company, so let's get straight into it. I'll take the biggest one first. This is from a company you've no doubt seen on Mailbag and heard of before, Tekbox Digital Solutions. They make cool niche products you've seen before. They're from Vietnam, so hi to all my Vietnamese viewers. And I'm not sure where Vietnam ranks on the scale of viewership. I have to check my survey results. If I remember, during editing, I'll see how many subscribers I've got from Vietnam. Anyway, Tekbox, they make, you've seen them before. Not only have they done did they do an electronic load I've got over there, I think? Yes, and they also did a, all right, I'll use the new thing. Beautiful. Right tool for the job. But this just looks cooler. And they make the EMC measurement stuff. So, oh, it's double boxed. Hang on. Ta-da! Almost there. So let's have a look. Yes, EMC testing stuff they've done. Whoa, look. We have, comes padded for our protection. And I think we're going to like this. This is definitely not something that I can demo on the Mailbag. It's something I will most definitely do a second, like a dedicated video on, but this is schmick. Check it out. It is a, it's the, for those playing along at home, the TBL-C08 Artificial Mains Network. Wow, check out this puppy. This looks like a real top quality bit of specialised kit. So that one was basically a mains AC LISN device, as in an acronym listener, for you know, EMC compliance testing. We've looked at the LISN before, but it was just like the little black box. This is like a better dedicated solution for just, you know, plug your mains appliance in and get RF out, hook it up to your spectrum analyzer and see if it passes, or it's designed for pre-compliance testing, not actually for compliance testing. So like a compliance lab probably wouldn't use it. They'd have their own stuff. It's a pink lightsaber. No, what is it? It's obviously all the accessories for this. We have a LED light fluoro tube. Well, it's a LED. It's got a LED tube. Socket for LED series TA tube. Socket not IEC compliant. What the? Okay, so obviously they want to use this. We can use this as a test device. It could be like a really leaky, crappy tube. Who knows? Yeah, it looks like a One Hung Low brand eBay one. Product. Oh, EMC View pre-compliance. That's right. They've got, that's right, they sent me an email. They sent me some software apparently, or something that plugs into my Rogaine DSA 815 spectrum analyzer and use it for pre-compliance testing. So, cool. Oh, and we've got the little, it's an attenuator set. Oh, oh yeah, oh yeah. Oh yeah, baby, look at that. Awesome. Attenuator set. One of them goes to 6 gig, the 10 dB one from DC to 6 gig. That's practically DC to daylight. Awesome. So yeah, an attenuator set. Geez, that'll come in real handy. We've got a shitty little plug pack here, a cheapie with a test report. So we can actually look at that and change it to attenuator settings. Yep. So this, we can do a complete video on EMC pre-compliance testing. Fantastic. And then they've sent another one, which is a genuine Philips LED T8 lamp and IEC compliant socket. Anyway, so no doubt the Philips one will be much better and possibly compliant compared to the One Hung Low cheapie. But yeah, it requires complex setups to do all this testing, so I can't do that on the Mailbag, but let's crack this puppy open. And yes, this is work experience at the EEVblog lab.
He's loving it. Another work experience student who doesn't want to be on camera, but that's all right. He's having fun, learning stuff. This is educational, surely. So this is a beautiful example of a specialised bit of kit, in this case for mains conducted mode pre-compliance testing. And sorry, as I said, it takes a lot of setup to actually demo one of these and like do it properly. So I'm going to have to leave that to a separate video. A lot of people have asked for a pre-compliance testing video, and this is basically a complete solution, along with they've given me some sort of software for my Rogaine spectrum analyzer as well. So it's a nice bit of kit. It's got flip feet. It comes with different, they've given me the one with the Australian plug, none of that American or a Yankee or European rubbish. And it basically has got an attenuator built in, and you can choose whether or not you want it from the neutral or from the active phase as well. It's got the RF output, which goes to your spectrum analyzer, and a switch to either connect directly through to mains earth or through a inductive filter there. And very nice, an artificial hand. We'll have a look at the manual which tells us about that, and separate case earth. It's a very nice specialised bit of kit. I love it. And it goes for about $650 US, which might seem like a lot, but if you're doing pre-compliance testing, $650 plus your cheap Rogaine spectrum analyzer, whatever that's the going rate for that spectrum analyzer is these days, it's pretty cheap to do EMC pre-compliance testing with something like this, rather than spend huge dollars, many thousands of dollars, you know, crossing your fingers, going to the testing house and wondering if your product's going to pass. With something like this, you can do what's called pre-compliance testing, hence the name, before you get to the compliance house, and good confidence that the product which you plug into here is not going to is going to be within the acceptable limits or not, grossly out. It's not as accurate. They wouldn't use this at a test house, for example. They might, but they probably have, you know, much more characterized ones. But yeah, for pre-compliance testing, it's quite reasonably priced. I mean, you can build this yourself. It is just a basic LISN, it's called, which is a line impedance stabilization network. And we'll have a look at the schematic in the manual, but there's not much to it. So you can actually build one yourself, but having it all in one box is just very nice. And on the back, we've got a big-ass strap. And you might be wondering, what's that for? Well, we'll have a look at the manual. This actually bolts down to the shielded plate, which all of this would sit on if you're going to do this properly. You wouldn't just use it on the bench, just flapping around in the breeze like that. You know, you've got to at least do it properly. Let's go to the manual. And I do like the little manual that comes with it. It's quite comprehensive and informative. There's the features for those playing along at home. So as we'll see, it's just a basic 50 microhenry AC LISN for conducted mode measurement. And this is the basic system configuration for it. It's the RF output, 50 ohms, goes to your spectrum analyzer. Here's your mains supply input. And then it's basically outputting that mains and going to your device under test. But your device under test, what you're testing for, of course, is that does it emit any conducted interference on either of the lines here? Any EMI? Is there any RF EMI on there coming back? So it basically just measures that coming back and taps it off to the receiver analyzer. And we can see that over here. As you can see, there's not much in here. Yes, you can build it yourself if you really want to. You know, instead of paying the $650. You know, design your own. But by the time you spent the effort to characterize it and make sure it's okay, you've spent more than your $650 in time. So, you know, by all means, if, you know, time is not money to you, yeah, you know, you can make your own. But hey, this is purpose designed. It just works out of the box, and Bob's your uncle. So as you can see, the device under test, or the equipment under test here, it's just AC coupling that off here, and that's what that switch on the front did, and it's selected between either the neutral line or the active line up here. It just AC couples that off, or you can just earth it with 50 ohms there, and that's all it is. And this is how you typically set up a conducted noise pre-compliance system. There's our 50 microhenry LISN here, device under test. There's a big ground plane, hence that big ass earthing strap on the bottom. You'd power it with an isolation transformer. You'd have your spectrum analyzer also sitting on there, just one big ground plane like that, because once you have cables coming off here like this coming out, then you're now no longer on the ground plane, and you can screw everything up. So don't do that. It's a one big earth metal plate. And no, you can't just use your anti-static mat. You can't just use a static dissipative mat. Not good enough. And there's the impedance versus frequency and the frequency response for those playing along at home. And this is really interesting. It's an artificial hand designed for pre-compliance testing of handheld devices where you've got to simulate the person's hand in the thing. And they didn't supply one of these. You'd have to, you can probably buy specific ones that'd be incredibly niche and that pretty much maybe only the test houses have them. But, if you can get one or make one or whatever, I haven't looked into the details of making one like that. But that comes from the CISPA 16 standard, by the way, and just how you should do that to simulate, because you've got to have a controlled simulated thing that's used by the test houses. You can't just have somebody holding the device inside the test chamber. Oh, isn't that gorgeous? Love big coils. I didn't expect them to be so big, but look at this, beautifully wound. They've got not sure what kind of former that is in there, but anyway, these are just beautiful. Oh, look at this. Where was the schematic that we had here? This is basically what we're looking at. Right there. There you go. And we've got the big 50 microhenry inductors in there. They're just gorgeous. But that is not completely representative of what's actually in here. Because check it out. I mean, these would be your 250 microhenry jobs in here. But look. Oh, look at that gorgeous Vichy cap there. Oh, but look, they've got some additional resistors under here, okay? So these are in series. These are 4 inductors in series to make up what's shown on the schematic as a single 50 microhenry. And then we've got some, 68 ohm resistors down in there. So, yeah, it's not entirely representative of what's inside this thing, but isn't that just... Oh...
Holy Toledo! Somebody had fun.
Well, somebody's had fun with the gunk machine. Look at this. They've just completely gunked all of the main stuff. Anyway, proper mains connection there. And look, they've just gone to town. Gone crazy gunking these things. But isn't this thing just gorgeous? It's worth every one of its $650. And there's the money shot for all you Vichy capacitor fanboys. And the front panel RF board here, beautiful. And I love the just the attention to detail. And they've kept all the output mains wiring short as, which is important. Look at this. This is hilarious though. They've 3D printed this, obviously. So is this like a last minute edition, which they'll fix in more production versions or something? Or they just, they wouldn't make these in massive volume. It's not like they're making tens of thousands of these things. So, yeah, they just needed this 3D printed shim here just to clip in the AC connector on the front. Okay, it works. It's neat. So you'll notice that there's no actual active circuitry in this thing. So the high-pass attenuator and high-pass filter attenuator limiter thing, it's basically just a passive board there. But yeah, isn't that done nicely as well? Yeah, you can build your own, but look, this is just so professional. Fantastic. So that gets a massive thumbs up for construction quality. Fantastic. And yeah, I'll try and get around to doing a dedicated video for this because a lot of people have asked for it. RF attenuator goodness. Imagine if you tried to take that through airport customs. You'd probably have some explaining to do.
Hi to all my Australian viewers, in particular Western Australia. This one comes from company Unknown. I won't tell you the address, but it comes from Osborne Park. It's strange. I'll give you a spoiler alert. Description, paper. I don't get it. Okay. The description is paper. So, we've got a note. It's like a ball rolling around in something. Oh, I thought I could smell it because I'm a connoisseur of 3M adhesive. Whoa, it's good stuff. Oh, genuine 3M468MP, 200 MP adhesive. Thank you very much. Please keep company name confidential. It wasn't even on there. Okay, it doesn't even have a name. Thank you very much. Also included, one of the company's transmitters. Okay, it's in a no-name box. Proudly designed here in Australia for a 2-minute teardown. It's a synthesized 440 to 470 megahertz 5-watt transmitter. Fantastic. Used to send messages to telemetry receivers, pages, and voice radios. Fantastic. 2-minute teardown, Australian design transmitter. RS-232 in, RF out. Beauty.
Proudly designed in Australia. No name box. Let's check it out. Here we go. Whoa, we're in like Flynn. Look at that. Couple of squiggly traces there. They're adding some inductance in there, are they? But yeah, whoa. Look at that puppy. And they're using the big, huge tabs for heat sinks, obviously to set the address on the thing. Oh, actually, well, that's on the that's not on the RF side. Oh, yeah, set the address of the thing for the RS-232 input there. We've obviously got a SOT 223 voltage regulator over there, and that's quite neat. Notice the separated ground plane here that separates the RF section from the digital section. Obviously, we can't see the micro in there. It's got an in-circuit serial programming port, so that's on the bottom. And that's an ST Micro PD55008. Yep, an RF power tranny. And you would have thought that they'd be able to get a better thermal profile and reflow that puppy properly, but yeah, that's pretty messy. It does the job though. Like, a lot of thermal mass there. Maybe they had reflow heat issues, so they've, you know, soldered it on by hand. 68HC processor on the bottom here, just some jelly bean logic. Soldering here's how you doing. What's going on there? And look at that. Frosty the Snowman on those D9 connectors. Bloody lead-free solder. A VTXO? Why so serious? It's a rigid coax. That connects the RF, it connects the two sections. Why have they gone to that effort? I don't know. So I'm not really sure I understand why they need... Look, so many bypass caps in the digital section. I mean, what's going on there? Wow. Do they get a bargain sale at the Shenzhen market? It's a nice looking encapsulated coil there right next to our RF transistor. That's an interesting little beast. So thank you, Person Unknown from Company Unknown. That's a neat little RF, like, you know, basically single transistor RF amplifier for the 440 to 470 meg 5-watt job. You know, how many kilometers that translate to with, you know, a decent antenna with a decent amount of gain. I don't, you know, it'd be, you know, tens of kilometers transmission or something like that for data rate. So it doesn't say anything about maximum data rate and things like that. You know, probably your maximum RS-232 rates it could handle with no issues at all. Interesting little beast.
Another one from Australia. Bloody ripper. This one's from Melbourne, Burke Street. One of all my Melburnian viewers. We like Melbourne as much as we like to fight Sydney and Melbourne. You know, who's better? And Sydney, of course. No, Melbourne's like, I really love going to Melbourne. If I didn't live in Sydney, if I had to live in like a major capital city, I'd be living in Melbourne. So thank you very much, Unknown Person or John. He was cleaning up his workshop and found 3 boards. We've got an Ericsson NTU network thing. Is that it? I don't know. We've got a Ericsson AX Lee, whatever, line interface card from 88, and Alcatel card. Ooh, that's interesting. It's got some interesting relays on that. Probably relays or something. Probably really ridiculously expensive. 2-minute, well, not a teardown, 2-minute loop.
Wow, an Ericsson NTU network termination unit, X21 BIS interface. Thank you very much. Hands up if you used one of these babies. This would have, well, this one dates from 1986. But yeah, I mean, the technology predates that. Okay, what the hell is that? That, believe it or not, is the micro. It's a Hitachi HD 63P0. It's got like a couple hundred bytes of RAM, but it has this novel feature of having these piggyback machine pins on top that you plug your EEPROM into, your program ROM into. That's brilliant. It's absolutely brilliant. It saves the PCB space. I mean, all the bloody traces have to just go in parallel anyway. You're just pissing away your space on your PCB. Why didn't all micros come like this back in the day? Why don't they still come like this? That's by far the most interesting thing on here, and there's nothing else too interesting on there. Well, I don't know what that other big beastie is. Yeah, 86 date code, so definitely 86 vintage. And this is an Alcatel analog line card, 16 channel from 1996, or recent. I can really dig the symmetry on this thing. It's, you know, it's very pleasing to my eye. Being the PCB layout guy that I am, it's just lovely. Look at that. I wouldn't even want a data sheet half of the stuff on here. It's probably all like custom stuff, or, you know, application specific stuff, definitely. But look at all the lovely relays. Geez, you'd salvage this board just for the relays. Fantastic. But one of the more interesting things on here, look, these ceramic hybrids, where they use their fancy surface mount capacitors on there. There's not much else doing on there. I mean, they're basically blank on the back like that. But Bell is that, you know, analog line. Well, it's an analog line card, so that's like a ringing, like a Bell ringing, a ring detect type thing to see, like, if the input to this phone line is ringing, you know, this gives an output, something like that. So it's obviously some sort of modular functionality like that. And they've got another couple of hybrids on there. Look at that. What do those puppies do? Couple of trannies. And for all you MILF fans, there we go. The back's just covered in MILFs. Oh, MILFs as far as the eye can see. Love it. Now this funky looking card here is a 4-line line interface card. It's an Ericsson AXE Li, or whatever. Once again, big reefer caps there. They're probably going to fail. Some more hybrid. Yeah, are they hybrid? They'd be, well, actually, we've got some laser trimmed. Look at that, some thin film laser trimmed thing. Whoa, what's going on there? They love their hybrids, you know, these telecoms companies. Geez, is that a Rockwell? That's a Rockwell symbol, isn't it? Memory serves me correctly? Or am I, see if I can, maybe I'll try and Google that. But anyway, 87 vintage, check that out. And once again, these are like their TI parts, but these are all, you know, custom designed for these particular applications. But, oh, it's neat. Look. Special relays. So thank you very much, John, for sending those in. It's always interesting to see telecoms tech like that. You know, there's a lot of engineering that goes into these, and these cards would have been, you know, very expensive and purpose designed for the telephone exchanges and stuff like that, and pretty much entirely redundant these days. But, you know, they were still running individual lines back in. You know, every house, every office had a pair coming back to the local telephone exchange, and they'd go into things like this. Neat. Now I sucked out one of these little hybrids here, and check it out. I mean, look, there's these pins are shorted across here, here. So there's just two separate, what I can measure as resistive elements, 115 ohms each. So they're matched, you know, thermally matched because they're on the same ceramic substrate maybe, but like why? Why the big deal? I don't get it. Anyone? And reefer? Okay, didn't know reefer were into doing ceramics. But, you know, they got the contract for the capacitors on here, so they went, oh, yeah, we can supply those as well. No worries.
Got one from the United States of America. Thank you very much, Jeff Orr from Milpitas, California. That kind of rings a bell. Name rings a bell, and the suburb rings a bell. I wonder how many viewers I've got in Milpitas, or whatever it is. Don't know. The stats don't get that detailed. So it's just got, spoiler, something broken. Let's have a look. Oh, geez, padded for our protection. Oh, that's an, magic smoke's been released from that. Woo! That's an interesting board. What on earth is it? Got this board as part of an eBay purchase. It's dead. So it's got two ASIC blades from a Gridseed G-Blade Scrypt. Oh, Litecoin, Dogecoin. Okay, for coin mining. It's a cryptocurrency miner. Designed to have two of these blades inside an enclosure, a big-ass fan at the back. Okay. So, yeah, it really doesn't pay you to mine the Bitcoins anymore, does it? I don't believe. I think it's gotten to the point where, no, the power just costs you more than because it gets harder and it gets progressively harder to mine the coins as you get towards the 20 million or so maximum number of Bitcoins. But this doesn't do Bitcoins. It does Litecoin and Dogecoin. So I guess you need a different custom ASIC for that. Anyway, let's take a look at it. It's called Gridseed.
And Jeff has kindly sent some detail here about these Gridseed G-Blade Scrypt things that do Litecoin and Dogecoin mining. And yep, it's had the magic smoke escape. We'll take a look at that. Uses 72 meg Cortex M3. That's not for doing the mining. That's just for control and stuff like that. So it uses 40 ASICs on each blade. Total power consumption at full speed is 140 watts. Most people use an ATX power supply for this thing. These are able to do Scrypt and SHA 256, but the blade is only using the Scrypt functionality. Yes. Anyway, thank you very much, Jeff. And that's what it looks like when you separate the two units. Big heat sink in on the back, and it just blows air straight through the center like that. And this is what the board used to look like before it was damaged. The blue heat sink was not present. Overclockers use it to do voltage mods. Okay, so that's what it used to look like. Look, we've got a DC barrel jack here. So that is what it was. This is what it is now. Ugh. And yes, it smells as bad as it looks. So this is beyond just the magic smoke escaping. This is full-on flame territory. Look, you can see how the fiberglass PCBs are constructed. They're woven fiberglass like that. That's how they're so strong, and then they're epoxied, basically covered in epoxy. But that is ridiculous. That's just caught alight. That's just like flames have just engulfed this thing. How do you do that with just a DC barrel jack and some connectors up here? Whoa, yeah. Whoa, oh, wow. Wow, oh. Oops. Wow. Anyway, no, didn't we see that? Oh, look at that. The laminates, look, the copper foil has come up. You can see the copper foil on there. It's just peeling right off, revealing the woven fiberglass underneath. We saw this on the NES alarm control panel way back, didn't we? It was one of the decoupling caps, wasn't it? Shorted out or something, and then it just caught alight, and yeah, well, yep, there we go. Caught alight, and yeah. And this is actually what FR4's all about. You know, here at FR4 PCB, it's actually a flammability grade, flammability rating, whether or not, you know, your board's going to catch on fire and stuff like that. Yeah, this one obviously did. And there's your custom ASICs for those interested. And there's the back side of that. Obviously, they're getting the heat out through the bottom pad on the chip, and then, of course, they would thermally bond these over to little heatsink. You know, there's probably a machined aluminium block that has a little machined out, a machined thing. All the surrounding stuff's machined out, and then it's left a pad which then just a big block of aluminium which then just contacts on there and extracts all the heat out.
Hi to all my Vancouver, British Columbia viewers, especially Brian L. for sending this one in. We've got a demo of something used, so I'm not... Let's have a look. Rogaine? Yeah, what's Rogaine? It's obviously not that, surely. Greetings from Vancouver, Canada. Yes, I started teardown this. Oh, Rogaine electronic advertising gadget. Oh, right. We've had one of these years ago, and these are absolutely fascinating. If it's like the ones with the built-in screen. You remember the one, it was in like Playboy magazine, I think it was, or something like that. They had an electronic advertisement. I won't open it because it could auto-play. So I'll get this on the main camera. And expert, probably better in the hands of... I started a teardown. The battery runs out of power after about 30 seconds. Yep. Okay. Cool. Let's check it out.
So this is actually not Rogaine, it's an advertisement for Rogaine. And it's not just a printed advertisement, it's an electronic advertisement. We've seen these before. Whoever came up with this concept should not be allowed to work in the industry again. It's so wasteful. It is like an LCD screen and usually like an ARM processor or something similar. And when you open it, ta-da, there it is.
Have you heard about the latest option from Rogaine? Twice a day Rogaine 5%. A 5% minoxidil topical foam is indicated for the treatment of male androgenetic alopecia on the top of the scalp.
Alopecia?
Also called the vertex. These videos cover Rogaine's efficacy, tolerability, and safety profile, and will introduce you to the Rogaine patient brochure. Press any button.
Press any button. I don't know. Patient brochure. Oh, okay. Efficacy. Okay, efficacy, tolerability. Yeah, and it'll play a different video. So all it is, it's a little ARM computer in there with like an SD card or memory that flash memory that contains these pre-recorded video clips. The cheapest ass, reject LCD they can find from the Shenzhen market, because they have to build these down to a ridiculously low cost because they're designed to be thrown away. You open it. Yeah, it's obviously got it. Yeah, I can feel a magnet in there. It's got a magnetic playing thing. There we go. Efficacy.
Rogaine foam 5% was...
And like
Rogaine
unbelievable.
Foam 5%
patient brochure.
To help you help your patients, Johnson & Johnson has developed a patient education
brochure. Okay.
To assist
patient
you with
brochure. Oh, okay. So it's probably designed for doctors' offices or something, is it? Maybe. Maybe, because power is not enough, it said. Power is not enough. The world is not enough. So maybe Brian knows or someone else knows. If you've seen one of these, have you seen one in like a doctor's office or a hair loss clinic, thing or something like that? Because like we've seen these before in, I believe it was like Playboy magazine, where they had an advertisement for, I can't remember what it was, but they inserted it in there, and you get your magazine and you get this ARM computer in here, and apparently everyone was buying that edition of Playboy or whatever it was, not because they wanted, well, okay, decent enough to look at, but no, everyone reads it for the articles. But you got a free like ARM computer in there, and you could hack it and stuff like that. So maybe this one didn't come with a magazine or something like that. It looks, like it wouldn't. It's not thin enough to go into the magazine. The other one was really thin, but look at this. That's pretty how you doing. There you go. That's the charging port where they charge that puppy up. Anyway, let's rip into it. I mean, but like, okay, if they're designed to make these in hundreds or a few thousand to use in doctors' offices as a little advertisement, okay, I'm okay with that. But the ones that just come in magazines or anything else designed to be disposable after a single ad is played by the average end user, then no, it's just, yeah, it's a disgusting concept. Because I really don't want to live in a world where, something like this as a disposable advertisement is acceptable. That's not the kind of world I want to live in. And look at this. Oh, that's how you're doing. That's what you want to see. Look at that. Wow. Bodge Central. Fantastic. But that's all it has to be. I mean, they've cobbled these, like the switches, just cobbled together. Look at that. And then wired over. They've paid someone peanuts in China to assemble this thing. And as I said, it used whatever they had available. Even different batches of these might use different things. Anyway, it's going to be pre-programmed into the flash memory or the video. It doesn't look like it has a micro SD card or anything on this particular one, but it's just going to have an ARM processor, and there's our battery in the corner. That's One way to get rid of your toxic chemicals, just whack them in the cheapest possible battery. And there's the Hall effect sensor, because there's a magnet in the top. Where is it? There's a magnet in there. So yeah, I can feel it. I can feel the... See? You can see the outline of the magnet in there. And that's just a little Hall effect sensor that detects and switches the thing on. So, yeah, there we go. Yeah, got it.
Have you heard about the latest option from Tidal Topical?
Oh, shut up. Well, shut up. Come on. Oh, bloody hell. Anyway, they have just hacked these together. They've obviously gotten a contract to make, you know, well, hopefully only a few hundred of these or something. But who knows? Okay, what is an E200? By the looks of it, that's the main processor. So I got no idea offhand what that puppy is. But like I said, it's got to be some sort of ARM processor, some ARM application processor, app processor with LCD driver and everything built in, because they obviously don't have a separate LCD driver. It comes straight from that. So, yeah, probably running some version of Linux. So I think these are absolutely horrible. It almost reminds me of that, you know, world's worst tablet computer teardown. Not quite, you know, it's like order of magnitude better, but, you know, still the how you doing wiring and it's just slapped together just to do the job, you know, and it looks good from the outside. So, you know, like, but they're just awful. And if they're producing this in mass volume, Elon, get me to Mars. So thanks to everyone who sent something in to today's mailbag. If you liked it, please give it a big thumbs up. And as always, discuss it down below. Catch you next time.